German test pilots stared at the massive engine in disbelief. The captured F4U Corsair sitting in their hangar looked impossible. This American fighter produced 2,000 horsepower. Their best German fighters barely reached 1,700. Major Hans Kolbo shook his head as he walked around the aircraft. "How did they build something like this?" he muttered. His colleague, test pilot Friedrich Weber, was equally stunned. The Pratt & Whitney R2800 engine was 50% more powerful than anything Germany had. This wasn't supposed to happen. German pilots had dominated the skies for years. Their Messerschmitt Bf-109s and Focke-Wulf 190s were the world's finest fighters. Or so they thought. The story had started 3 weeks earlier in Norway. Lieutenant Matali of the Royal Navy's Fleet Air Arm faced disaster on that cold July morning in 1944. His F4U Corsair, serial number JT404, was failing over enemy territory. The engine sputtered and died. Altitude dropped fast. Below him stretched German-occupied Norway. Capture meant interrogation and prison. Maybe worse. Matali had no choice. He aimed for a field near Bodø and prepared for an emergency landing. The bent-wing fighter hit the ground hard. Matali survived, but his aircraft was finished. German forces quickly secured the crash site. They had captured something extraordinary. But let's go back further. Back to 1938 when this revolution began. The U.S. Navy wanted something impossible. They issued requirements for a carrier fighter that could exceed 400 mm. Most naval fighters of that era barely reached 350 mm. Carrier operations added weight and drag. Strong landing gear, tail hooks, folding wings all reduced performance. Chance Vought Corporation accepted the challenge. Their chief designer, Rex Beisel, knew conventional approaches wouldn't work. They needed revolutionary thinking. Beisel's team created the inverted gull-wing design. It looked strange, but it solved multiple problems. The Navy wanted the largest, most powerful engine available. The Pratt & Whitney R2800 with its 18 cylinders and 2,000 horsepower. Such power required an enormous propeller, 13 feet and 4 inches in diameter. But how do you fit that on a carrier fighter? Normal landing gear would be impossibly long and heavy. The inverted gull wing was pure genius. It angled down from the fuselage, then back up toward the wing tips. Landing gear mounted at the wing's lowest point provided propeller clearance. The gear legs stayed relatively short. This design offered aerodynamic advantages, too. The wing met the fuselage at 90 degrees. This reduced drag at the critical junction point. On May 29, 1940, test pilot Lyman Bullard took the prototype XF4U-1 up for its first flight. He pushed it to 404 mPh, the first American fighter to exceed 400 mPh in level flight. This was stunning. German Bf-109s and British Spitfires struggled to reach 360 mPh. The Americans had jumped 40 mPh ahead, but speed was just the beginning. The Corsair incorporated innovations years ahead of their time. Landing gear retracted completely into enclosed wheel wells. The wing surface stayed perfectly smooth. Oil coolers mounted flush with the wing's leading edge using carefully designed air intakes. The armament impressed everyone. 650 caliber Browning machine guns in the wings. Each carried 400 rounds. This concentrated firepower could destroy most aircraft with short bursts. The high-velocity rounds worked effectively at longer ranges than smaller weapons. Yet early service brought tragedy and frustration. The long nose housing the R2800 engine created severe visibility problems. The cockpit sat so far back that pilots could barely see over the nose during carrier landings. Carrier trials in late 1942 were disasters. Test pilots struggled to land safely. the Navy temporarily abandoned carrier operations with the Corsair. The fighter designed for naval use was too dangerous for carriers. Instead, they gave it to the Marine Corps for land-based operations. The Navy adopted the more docile Grumman F-6F Hellcat as their primary carrier fighter. This decision proved fortunate for the Marines. They desperately needed high-performance fighters in the Pacific. Marine squadrons had been flying obsolete Grumman F-4F Wildcats. These were outclassed by newer Japanese fighters and couldn't intercept high-altitude Japanese bombers. Marine Squadron VMF-124 arrived at Henderson Field on Guadalcanal in February 1943. The Cactus Air Force had been struggling to maintain air superiority over the Solomon Islands. Japanese bombers regularly attacked Allied positions. Existing Allied fighters often lacked performance to intercept them at high altitude. The Corsair's combat debut on February 14, 1943, was disappointing. During a bomber escort mission, the mixed American formation was attacked by Japanese fighters. 8 American aircraft were lost, including 2 Corsairs. One F4U was destroyed, colliding with a Japanese Zero. Hardly the dominant performance expected from the new superfighter. But Marine pilots quickly learned to exploit the Corsair's advantages while avoiding its weaknesses. The key was avoiding turning battles with Japanese fighters. They were more maneuverable at low speeds. Instead, use the F4U's superior speed and climb rate to control engagements. Corsair pilots developed high-speed pass tactics: attack fast, then escape before the enemy could respond effectively. Lieutenant Kenneth Walsh of VMF 124 became the first pilot to demonstrate the Corsair's true potential. An experienced pilot flying Marine aircraft since 1938, Walsh understood how to use the F4U's performance advantages. On May 13, 1943, Walsh shot down 3 Japanese aircraft in a single mission. The first Corsair ace proved the bent-wing fighter could dominate when flown properly. Word spread quickly through both Allied and Japanese ranks. Japanese pilots, accustomed to their maneuverability advantage, faced an opponent that could simply outrun them. The F4U could accelerate away from trouble, climb above attacking fighters, and dive at speeds Japanese aircraft couldn't match. For the first time in the Pacific War, Japanese pilots found themselves consistently at a disadvantage in fighter combat. The psychological impact was significant. They began fearing the distinctive sound of the Corsair's engine and propeller combination. It created a characteristic whistling noise during high-speed dives. Japanese forces nicknamed the F4U Whistling Death. As 1943 progressed, more Marine squadrons converted to Corsairs. The aircraft's combat record continued improving. By year's end, Corsair pilots achieved an 11-to-1 kill ratio against Japanese aircraft, almost unprecedented air superiority in combat history. The fighter rejected by the Navy for carrier operations was proving itself one of the most effective air superiority fighters of the entire war. The Corsair's impact extended beyond air-to-air combat. Its robust construction and powerful engine made it an excellent fighter bomber. It could carry substantial bomb loads while retaining air-to-air capability. Marine squadrons used Corsairs for close air support missions, attacking Japanese ground positions with bombs and rockets, while maintaining ability to defend against enemy fighters. This versatility became one of the F4U's greatest strengths. Unlike specialized interceptors or ground attack aircraft, the Corsair performed multiple roles equally well. It could escort bombers on long-range missions, conduct fighter sweeps, attack ground targets, even perform reconnaissance missions. This flexibility made it invaluable for Marine commanders operating with limited resources. They needed aircraft that could adapt to changing tactical situations. Meanwhile, across the Atlantic, German aviation experts followed Allied aircraft development with keen interest. Intelligence reports from the Pacific described a new American fighter with extraordinary performance. But the F4U's full capabilities remained largely unknown to German analysts. They had examined captured American aircraft before. P-51 Mustangs, P-47 Thunderbolts, and P-38 Lightnings had all been tested at German facilities. But the Corsair, operating primarily in the Pacific theater, remained an enigma. German pilots flying the Luftwaffe's premier fighters had grown confident in their aircraft's capabilities through years of European combat. The Bf-109 in latest variants could reach nearly 400 mm with excellent climb performance and maneuverability. The FW-190 was considered by many the finest all-around fighter in the world, combining speed, firepower, and ruggedness. But intelligence reports from the Pacific suggested the Americans had developed something extraordinary. Descriptions of Corsair performance seemed almost too good to be true. Speeds exceeding 440 mph, climb rates surpassing most German fighters, firepower that could destroy enemy aircraft with short bursts. German aviation experts remained skeptical. Were these reports exaggerated? Were Japanese opponents simply inferior to seasoned Luftwaffe pilots defending the Reich? The capture of Lieutenant Matali's Corsair in July 1944 would provide German experts their first opportunity to examine the F4U closely. The aircraft was transported by boat to Norway, then shipped to Germany for detailed analysis at Erprobungsstelle Rechlin, the Luftwaffe's primary aircraft testing facility. At Rechlin, German engineers and test pilots had examined captured Allied aircraft throughout the war. They had tested American P-51s and P-47s, British Spitfires and Hurricanes, Soviet fighters captured on the Eastern Front. Each evaluation provided valuable intelligence about Allied capabilities and helped German designers improve their own aircraft. Now they stood looking at this bent-wing American fighter. The examination would reveal performance capabilities that shocked even experienced German aviation experts. When German technicians began their inspection, they found an aircraft displaying sophisticated construction. All-metal structure, advanced aerodynamics, and that powerful engine. The R-2800 Double Wasp was significantly larger and more powerful than any engine used in German fighters. Weber climbed into the cockpit for his first test flight. He had flown every German fighter, plus many captured Allied aircraft. Nothing had prepared him for the Corsair's performance. The aircraft exceeded his expectations in virtually every category. Faster than any German fighter in level flight. Climb rates that matched or exceeded their best interceptors. Structural strength allowing G-forces that would damage other aircraft. Most disturbing was the realization that the Corsair represented a new generation of American military technology. Unlike earlier American fighters showing design compromises or manufacturing shortcuts, the F4U demonstrated engineering sophistication and industrial capability, suggesting the United States had fully engaged its technological resources for war production. The implications were sobering. If Americans could produce fighters of this caliber in substantial numbers, it would fundamentally change air power balance. German pilots, accustomed to meeting Allied aircraft on roughly equal terms, would face opponents with significant performance advantages. The air war over Europe, already shifting toward the Allies, might become even more challenging for the Luftwaffe. By mid-1944, Germany's aircraft industry struggled with material shortages, bombing damage to factories, and resource diversion to jet aircraft development. The opportunity to develop new piston engine fighters matching the Corsair's performance had largely passed. As the captured Corsair underwent testing at Rechlin, the air war continued evolving in ways that would determine nations' fates. In the Pacific, Corsair squadrons supported the American island-hopping campaign, providing air cover for amphibious landings and attacking Japanese positions throughout the Central Pacific. Each mission demonstrated the aircraft's versatility and effectiveness, building a combat record that would establish the F4U as one of World War II's premier fighters. The story of how American engineers created a fighter outperforming Germany's best aircraft represents more than technical achievement. It shows the transformation of American industrial capability, dedication of engineers and workers creating revolutionary technology under wartime pressure, and courage of pilots flying these advanced aircraft into combat against experienced enemies. The full impact of the Corsair's capabilities would be felt later in the war, when improved versions demonstrated even greater performance advantages. The F4U that crashed in Norway was just the beginning of a technological revolution, reshaping aerial warfare, and leaving German pilots struggling to understand how Americans achieved such dramatic superiority in fighter design and performance. The captured Corsair at Rechlin represented more than just an advanced fighter aircraft. It was evidence of America's emergence as the world's leading aerospace power and a preview of technological dominance that would define the post-war era. German evaluation confirmed what Allied pilots experienced in combat. The F4U represented a new generation of fighter aircraft, combining speed, firepower, and versatility in ways previous designs never achieved. The stunned reactions of German pilots and engineers at Rechlin reflected not just professional admiration for superior technology, but recognition that air power balance had shifted permanently and decisively against the Luftwaffe. The bent-wing fighter that crashed in a Norwegian field had revealed the future of aerial warfare, a future where American technological and industrial superiority would reshape global power balance and establish the foundation for decades of aerospace dominance.